Hey everyone, this week we'll be going over a metric that really isn't talked about that much because there's better metrics at the pro level, but at the college level, I feel like this is a good metric to measure how frequently balls are hit hard. So it's called XBH over BIP, which is extra base hits divided by balls in play. And I have a little write-up right here. So it attempts to measure how frequent a pitcher gives up hard hits. Since we do not have exit velocity data at the college level, at least publicly, teams do have kind of some form of exit velo tracker for most, D1 schools, and then it trickles down. Maybe you'll see it, but what we have to do is kind of do our best to measure how often a pitcher gets hard. Generally, extra base hits are considered hard hit balls, so we will treat them as such in this scenario. So what we're going to do is go right into it by scraping a college team. We can do one at each level, and then we can see, compare and contrast and measure, how many extra base hits does a per ball in play does a player have. So what we'll do first is call our libraries baseball R and dplyr. Now, usually I call it tidyverse, but this time we'll just focus on dplyr. But I'll call these libraries into my console, and you have these messages, so on and so forth. But then what we're going to do is call, again, 3 different schools from each Division 1, 2, and 3 to get their pitching data and then be able to see kind of their extra base hits per ball in play. So what we're going to do first is we're going to call a data frame. I'll call it D1, call it whatever you want, and then another one, D2, D3. But actually, before that, we're actually going to do a function in the baseball R package called school ID lookup. And what that does is essentially allows you to look up the school ID that you need to get that NCAA scrape function. So we will say school ID lookup, and you can pick any team you want, but let's do Cal Poly. So we'll look them up, and you can see that there's Cal Poly Pomona, which is a Division II school, but we're going to focus on Cal Poly, and we're going to use the 2019 season. So you can see that their school ID is 90. So what we'll do next is, again, I'll call it D1 data frame, and we'll use the NCAA scrape function in baseball R. That team ID is 90, and that year that we want is 2019, and we'll say type equals pitching. And so we'll run this, and it should pop up, and it has all the pitching data you need, but looks like a lot of NAs, which is fine because it has information for every player. So one quick way to get rid of that is say D1 equals D1 piping operator. This is from the dplyr package, and we'll say filter and app, which is appearances, is greater than 0. So then that should bog it down to about 14 guys that made at least one appearance on the mound on the pitching side. Now, there's a quick way to replace these NAs, which is essentially what we'll need, but we'll also call some D2 schools and D3. So a D2 school we'll call, let's do Angelo State. So actually, no, I take that back. Let's do Colorado Mesa. So I'll just say school ID lookup, Colorado Mesa. We can see that their school ID is 11416. So we'll say NCAA scrape 11416, 2019 type equals pitching. And then essentially do the same thing as above. We'll say D2 equals D2 filter appearances is greater than 0. So now we have those, and then D3, we'll say NCAA scrape. We'll say the same thing, but this time we'll pick another school, and we'll say, let's do Co. We'll do Co College in the American Rivers Conference. And again, we'll say 150 is our school ID, so 150, and run this, Again, just the same thing. D3 equals D3, piping operator, filter, appearances is greater than 0. So that way we have at least one school in 3 different divisions. What we'll do is we're going to replace those NAs needed for the calculation of extra base hits over balls in play with 0. And so we have doubles allowed, triples allowed, home runs allowed, strikeouts, and then P dash official at bats essentially. We'll just replace those NAs with 0. And how you do that is you'll say D1 equals D1 piping operator, and then we'll call the tidy R package. And how you do that is just simply say tidy R double colon. And we'll call a specific function, which is replace NA. And then we'll call a list, which essentially we're just listing the variables that we need to list. So then we'll say doubles dash A, and the reason why there are those tick marks there is because there's a number that begins with the column. So if you don't put the tick marks there, that means R will think you're doing a calculation, and then R will fetch an error. So when you do have columns that start with a number, make sure you add those tick marks, or you can call them in quotes. Either way works. And we'll say double allowed equals 0, and you keep going down the line. So triples allowed equals 0, home runs allowed equals 0, and actually we need to put that in tick marks, because another thing is when you have that dash, R will think you're doing a subtraction. So home runs allowed equals not 9 but 0, and then pitches or official at bats essentially is also 0, and then strikeouts equals 0. So I will copy and paste that for each of them, so that way we have that information ready to go. Replace with D2 and D3. So run that, and run that. And then we can go in our data frame, and you can see that all of them are replaced with 0. And now we can get into that calculation. So again, I will just do it under each level. You can do it however you want. So I'll say D1 equals D1 piping operator, and then within the dplyr package there's mutate, which is essentially adding a column. And what we'll do is we'll say mutate, and we'll say add those tick marks, because we'll say XBH, and I'll just do an underscore, but that's essentially saying XBH divided by balls in play. So then I'm going to add a parenthesis, and we'll say doubles allowed plus triples allowed plus, ooh, I keep messing up there, plus home runs allowed divided by, and then those tick marks again, because again, with that dash, R will think that you're subtracting when you're really not. Pitches or official at bats minus strikeouts. And the reason why we're doing that is the at bats that end in strikeouts are removed because that's not ball in play. And then we'll say doubles, triples, and home runs. And then since that's kind of a complicated formula in terms of parentheses, I'll call it again, and then I'll say round XBH underscore BIP, and we'll just say 3. So essentially I'll go to 1 decimal point. And then I'll just copy and paste again, and I'll show you what that looks like shortly. But switch that to D2, and then switch that to D3. That way you can kind of see the differences at each level as well. I wanted to make sure that the official at-bats column was numeric, so a quick way to do that is just by saying data frame name equals data frame name, piping operator, mutate, P-OAB, again with the dashes, equals as.numeric P-OAB. So just to make sure, I will run this for each one because it may not be numeric in your case. as it was not originally numeric in my case. So we'll run that, and then we can run our extra base hits over balls in play. So now that we have all that, we can kind of see a quick little function or idea. So we'll say D1 piping operator, and we'll say select player, school, official at bats, again with the dash, strikeouts, and then extra base hit underscore BIP. So I spelled that wrong, so BIP. And then we'll say mutate balls in play equals P-OAB minus strikeouts. So that way we have balls in play. And then we will arrange by extra base hits underscore balls in play. So we'll run that. And actually I forgot to capitalize it. Sometimes this happens. We'll run that, and we can kind of see that, you know, some of these guys have a lot of balls in play. So 205% is really good. 6% is really good based on the amount of balls in play. And then we can break that down again at the D2 level. So then we can say D2, and then the same thing. You know, guys like Will Dixon, J.R. McDermott, you're going to see less balls in play because at the D2 level you played less games. But 5%, 7%, pretty good. 8.9%, also pretty good. And then lastly at the D3 level. So we will say that, and then we will say, we can break it down at co-college, and we can see guys like T.J. Deerdorf and Drew Schmidt, Zach Kamen, if I'm butchering their names, I apologize, Jack Green, all under 7% of extra base hits per balls in play, which is really good to measure. By looking up the D1, D2, and D3 extra base hits per balls in play in 2019, we have, based on that data, 10.3% of balls in play turned into extra base hits, 10.4% at the D2 level, and 9.1% at the D3 level. So when we go back into each of the schools, so like Cal Poly, for example, everyone who faced at least 100 batters, seems like only two did not meet that minimum threshold. So good on their end. They had 5 pitchers who threw to at least 100 batters be below that 10.3%. And then at the D2 level, Colorado Mesa, seems like that all of their pitchers that threw to at least 100 batters did have an extra base hit per balls in play under 10%. They had 2 guys that were right on that cusp, but below 10%. And then going to the D3 level, which is much lower at 9.1%, co-college, for all pitchers that had faced at least, we'll say 99 in this case, only one was above that extra base hits per balls in play. So I think this is great. It allows us to kind of see hard hit balls again. We're treating all extra base hits as hard hit balls. And I know it's not perfect, but we still have an idea based on the stats that we're given. So thanks for watching. I really hope you enjoyed this one. This is definitely a different kind of analytics idea in college baseball. But feel free to explore any more ideas or research questions. Leave a comment if you'd like if you want to see any more type of analytics in college baseball or anything that piques your interest. So again, thanks for watching. Like and subscribe if you enjoyed the video, and tune in next time. We'll go back into more advanced stats in college baseball.